Are you struggling to fetch data from a URL in your Android app? You're not alone. Many developers face this challenge, and today we're going to solve it together. I totally get it. It can be incredibly frustrating when your app doesn't respond as expected, especially after you've put in so much effort. You're definitely not the only one dealing with this issue. Let's dive into the specific question at hand. One user asked, "Why is my button not fetching data from the URL?" They mentioned that their code worked intermittently but now seems completely broken. Sound familiar? Let's explore this together. So what could be causing this issue? It often comes down to how asynchronous tasks are handled in Kotlin. If the thread hangs on the read text call, it could be due to network issues or improper coroutine usage. Let's break it down. And stick around. I have a crucial tip at the end that will help you avoid these pitfalls in the future. To begin resolving the user's issue, we need to ensure that the network operations are performed on a background thread. This prevents the main thread from freezing while waiting for a response. Next, the user should check the URL being fetched. It's important to ensure that the URL is correct and accessible. If the URL is down or incorrect, the read text function will hang. Now, let's modify the fetch async function to handle exceptions. This will help identify any issues that occur during the network call. Finally, the user should ensure that the main thread updates the UI only after the network call is complete. This can be done by using the with context function to switch back to the main thread. Fun fact, did you know that the first web browser was created in 1990? It was called World Wide Web, and it was a far cry from the apps we use today. Now let's look at the answers provided by other users. An alternative approach suggests using a view model to handle the networking logic. This method involves switching to the main thread to update the UI from a suspend function. The user recommends exposing the result as live data to the activity. In this approach, the fetch URL function launches a coroutine in the view model scope using dispatchers IO for network calls. The result is posted to live data, which the activity observes to update the UI. Let's move forward and look at another answer. An alternative approach suggests replacing run blocking with launch. This change prevents the main thread from being blocked while waiting for the coroutine to complete. Instead, using launch allows the coroutine to run asynchronously on the UI thread. That's the end of that answer. Let's see another perspective. An alternative approach shared by another user involves using a simple URL fetch method. They suggest using the URL class to read text directly from the API call. This method is straightforward and has worked well for them. They also provide a detailed example of managing the HTTP connection, including error handling and resource cleanup. This ensures that the connection is properly closed after use. Here's the tip I promised. Always test your network calls on a real device instead of an emulator. Emulators can sometimes behave differently, leading to unexpected issues. And there you have it. With these adjustments, your app should be fetching data smoothly. Remember, troubleshooting is part of the development process. If you found this helpful, subscribe for more tips and tricks.